Hello boys and girls, Miss Holloway here. You should be on reteaching 14-5, area and the distributive property. I'm going to start with showing you an example that's not on the worksheet. This is the way that I would teach it in school, so I want you to be a part of that. First, we have a region, and we can pretend that this is anything from a tiled floor to a carpeted floor to whatever would cover an area. So the first thing we're going to do is we're going to name the region, which means we're going to write down the length and the width of this region, because area equals length times width. So we will worry about this line right here in just a second that's separating them. So let's figure out the length first, and actually with this one I actually want to do the width first. So that would be 1, 2, 3. This is a 3 by 1, 2, 3, 4, 5, 6, a 3 by 6 region. And I did the width first for a reason, and I'll show you why in just a second. Okay, so the entire shape is a 3 by 6 shape. But if we had a separation right here to make it two separate shapes, then we have to do something a little different. So this is going to be shape A and this is going to be shape B. We'll pretend that there's a wall right here in your house and you want to tile this floor and this floor. So the whole floor is 3 by 6, but we need to know what just floor A is and what floor B is. So to do that, we're going to find the width and the length of just floor A. So we have 1, 2, 3 by 1, 2, 3 by 2. Now, to separate the number sentence, just like the floors are separated, instead of drawing a line, we're going to put this in parentheses, like that. Now let's find the name of B, floor B. We have 1, 2, 3, that's the width, times 1, 2, 3, 4, that's the length. We're going to separate that one too and put it in parentheses to show that this is A and this is B. Okay, so you might be thinking, well, all we would really have to do is take these tiles and add them to these tiles. You're right, that's what you do. So you're going to take floor A and add it to floor B. To solve this, you would take 3 times 2, which is 6, plus 3 times 4, which is 12, to get 18. But there is a simpler way to write this type of number sentence. Since the width is 3 for both floors, we are going to write that 3 first, and we're going to multiply it, because we're multiplying, by the 2 lengths. 2, and we're going to add, plus 4. Okay, so let me show you how that works. We're taking the width and we're multiplying it by both lengths to get the total area. If we take 2 plus 4, we're going to get 6. Bring down your 3 and your multiplication sign. 3 times 6 is 18, the same answer that we got here. So this is a longer version, this is a simplified version. And you'll see this on the worksheet. Okay, let's try some examples on the worksheet. We'll look at this example first. Suppose you separate a rectangle into 2 smaller rectangles. The area of the large rectangle is equal to the sum of the areas of the 2 small rectangles. You can use the distributive property to break apart facts to find the product. So the first thing we're going to do is write the multiplication fact that represents the area of the large rectangle, which is what we did first on the other page. So this would be a 4 by 5 equals 20 rectangle. Okay, so in this case, they also wrote the width first, 1, 2, 3, 4, and they put it first. If we look over here, now they separated it right here. So this would be A and this would be B. Now write the multiplication facts that represent the areas of each of the smaller rectangles. Okay, again, they started with the width, 1, 2, 3, 4 by 1, 2, 3, so that was 4 by 3. And B, 1, 2, 3, 4 by 1, 2. 4 times 2 equals 8. So then they took 12 and added 8 to get 20. You can write an equation to show that the area of the large rectangle is equal to the sum of the areas of the two small rectangles. So here was our original number sentence from above. Here is the simplified version, and here's the longer version. Okay, so this was floor A, this was floor B. See, there's 4 times 3, and there's 4 times 2. Because both of these start with a 4, and that's the width, they took the width and multiplied it by both of the lengths, and that's how you can write it in an equation like that. So let's do some together for 1 and 2. We're going to fill in some blanks here. Okay, the first thing we're going to do is we're going to name the entire region. 1, 2, 3. They have a 3 for us. 1, 2, 3, 4, 5. Okay. This section right here is the simplified version, and we're going to go back to that. I want to do this one first because I think doing the longer version first actually helps with the shorter version or the simplified version. All right, so this is going to be A and this will be B. 1, 2, 3, 3, 1, 2, 3. 3 by 3. Okay, for B, they actually switched it up. They put the width here instead of right here. But that's okay. If you wanted to put the width right here, you could. I like to do it that way to make it consistent. Times 2. Like that. Okay? So now we have the long version. Now let's do the simplified version. Here's the width. The width is the same. So we're going to put the width right here, multiplied by the 2 lengths, 3 and 2. 2 is already written, so we'll put a 3 right there. Okay, let's do number 2. The first thing we're going to do is we're going to name the region 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7. They have a 7 there for us. We'll wait on the simplified version and go to the longer version. This will be A, this will be B. 1, 2, 3, 4. And for B, 1, 2, 3 is the length. They have it there. For B, 1, 2, 3, 4 is there, and 1, 2, 3, 4 is the length. Now let's go to the simplified version. We're going to write the width first and multiply it by the 2 lengths, 3 and there's your 4. Okay. Now on the back side, the practice side, if you want to just do the long version of the distributive property, that's fine. Or if you would rather do the simplified version of the distributive property, that's fine too. It's up to you on which one you prefer. Okay, turn the page and do the practice side on your own. Good luck.